Let's look at a concrete example of a template. So here we have a pair template, and this pair template example is very similar to what C++ pair struct is from the utility library that is used for STL maps. So recall that STL maps store key value pairs, and in this diagram we have the key value pairs where the key is the student ID and the value corresponding to it is the GPA. Now you'll notice that when we declare our pair struct, we have the word template, the angle brackets, and then you'll notice that we have two different types. We can pass two different types. So we have the type name and T1 for the first type, and type name T2 for the second type. So now inside our struct pair, we have T1 is the type of first member of the struct, and T2 is the type of the second member of the struct. And here we just have a nearly empty constructor for our pair structs. We just initialize first and second with the values that are being passed to it of T1 and T2 for first and second respectively. Now inside of main, when we want to instantiate this pair, you'll notice that we use the name of the struct pair. We pass the parameters for the type we want for first and second. So here we want a pair where the first is a char and the second is a double. The name of our pair is P1, and you'll notice we pass to the constructor a char for first and a double for second. Similarly, if we want instead a pair that is a string for first and an integer for second, we declare the pair variable, the type, with the angle brackets, string for the first, int for the second. The name of our pair is P2, and we pass to it a string value for the first and an integer for the second to the constructor. And then when we want to access the elements of our pair, we can just use the dot operator because we just have the objects directly. So we could do P1 first, comma P1 second. We'll print out A and 3.1 from our first pair struct, and then P2 first, comma P2 second. We'll print high 4 from our second struct. Now, I'd like to discuss a few details about when we want to declare and define our own classes that use templates. So usually we ask you to put implementations of classes in a .cpp file, but for templated classes, all the implementation must go in the header file. That means we cannot put the implementation of a templatized class in a CPP file. It cannot be compiled separately. So let's see how this works when we are using templatized classes. So here we have our linked list class. It would be defined and implemented in our list.h, and it takes as parameter the type of values in the items of our linked list. So now inside main, we instantiate a linked list of integers and a linked list of doubles, and it is only when those instantiations occur that we actually generate the code for a linked list of integers, and then separately we generate the code for a linked list of doubles. Now a little aside about inheritance in templates. So when we use inheritance and we want to call the base class member function, we should use the this pointer with an arrow to call the function, or we should use the full scope of the base class. So here we have a templatized stack class which inherits privately from our list class, and here you'll notice inside the push function we want to just call the push front of the base class. It's basically just a wrapper function for the base classes, the list push front. So in order to call the list's push front function, we can use this pointer with the arrow operator to call push front, or we can use the scoping operator. And when we use the scoping operator, you'll notice that we have to give the full name of the base class, which is list, and we have to include the angle brackets with the T for the type to indicate that the base class is also templated. Now for nested members, and what we mean by that is if we have data or objects in functions that are not in the scope of the class and they still are generic, that they still have to have a type passed to them, we have to use the keyword type name. So here inside the top function for our stack class, we want to declare an iterator to a vector, but we need to specify that this needs to be templated also, and it's not in the scope of our class. So we are going to use the word type name before we declare our iterator to a vector of the type. So this is indicating that this type is still being passed to a parameter. And in this implementation example, we're, rather than using our inheritance from our linked list class, we are using as a private data member a vector of whatever type we're passing it. So we're using just vector for the specific data, but the type is being passed as a parameter. And since this iterator is not in the scope of our stack class, it's actually in the scope of the vector class. That is why we have to use the type name keyword before the declaration, and that will indicate that the type of the iterator is going to be passed as a parameter. Now inside main, when we declare an iterator to a vector of ints, we do not have to use the type name before it, because we actually specify that on the second line of main we want an iterator to a vector of integers. So those are just some details about using templates. So finally,